Okay, today we are going to finish up this unit with what's called the power of powers. And what power of powers means is you're taking a base that has an exponent and raising it to another exponent. So essentially you have a base with more than one exponent. You've got a base that has more than one exponent involved. So here, if we take 4 to the second power and we're raising that to the third power, essentially if we were to write this out in expanded form, like in a repetitive multiplication, we would be taking this 4 to the second power and we would be multiplying by 4 to the second power and multiply by 4 to the second power, right? We're doing this 3 times because we have this exponent of a 3 out here. This 3 is telling us we're going to take whatever base we had here, which happened to be a power, and repeat that multiplication 3 separate times. Well, we know from our rule, if we have a product of powers, that all we're going to do is keep that base and then add the exponents. We learned that the other day. Remember, product of a power, you keep the base because the base was all the same, so the base is going to stay the 4. And then we're going to take those exponents and just add them together. So we have 2 plus 2 plus 2. And this is going to come out to 4 to the 6th power. So 4 to the 6th power. Okay, I can show you again with a variable involved. It's the exact same idea, the exact same concept. We have y to the 3rd power. That's now being raised to a 4th power. So that means I'm going to take y to the 3rd, and how many times am I going to multiply y to the 3rd, y to the 3rd, y to the 3rd, and so on and so forth? I'm going to do this 4 times. Y to the 3rd times y to the 3rd times y to the 3rd times y to the 3rd. Okay, again, the exponent outside of the power is a 4, so I'm doing this repetitive multiplication 4 times. And then we just follow our product rule, where we keep the base is y, and then we add the exponents. So I'm going to take 3 plus 3 plus 3 plus 3. And this is going to come out to y to the 12th power. Okay, now obviously, like always, we don't want to sit here and have to write all of this out, so there's something that we can do instead. If you take a look, our exponents were 2 and 3, and then we ended up with a 6. Then we had exponents of a 3 and a 4, and we ended up with a 12. What operation do you think we're doing between the exponents to get to our final exponent answer? If you said multiplication, you are correct. So what we are doing is when we have a base, write this rule down, when a base has multiple exponents, as always, we always love to keep our base. We keep the base and multiply the exponents. We're keeping the base and then we're multiplying the exponents. Okay, so 2 times the 3 gave us that 6. When we did 3 times 4, it gives us the 12. The base did not change. The bases stayed exactly as it was. So let's go ahead and take a look at a couple of these practice problems here. We have 3 to the 2nd raised to the 3rd power. So essentially what that means, again, I'm going to keep my base. My base was a 3. I'm going to keep that base. And then what I'm going to do is I'm going to multiply I'm going to multiply my exponents. So I'm going to do 2 times 3 for my exponent. And when I do so, that's going to give me 3 to the 6th power. 3 to the 6th power. Okay, and now it doesn't have to just be a base with 2 exponents. It could be a base with 3 exponents. So we have 7 to the 5th, to the 3rd, to the 2nd. Okay, so that means our base is that 7, right? And now we've got 5, 3, and 2 as the exponents, so we're just going to multiply 5 times 3 times 2. That's going to come out to 7 to the 30th power. Again, all you're doing is keeping your base, and then you're multiplying your exponents here. Okay, so for problem 3, our base is m. Our exponents that we're going to multiply are 3 and 3, so we'll do 3 times 3. That gives us m to the 9th power. Okay, now take a look at problem number 4. Problem number 4, I have more than one base. I actually have more than one base. So what I'm going to do is I'm going to split these up into parts. I have 8 that's raised to the 6th power. I also have 3 that's raised to the 7th power. So I'm going to make sure that when I'm multiplying, I'm not multiplying these two exponents together, but I'm multiplying the exponent by the exponent that's on the outside. So this exponent that's on the outside is actually going to get multiplied to the 6th, and it's going to get multiplied to the 7th. This is kind of like distributive property. We're going to distribute, meaning we're going to take that and multiply it to each of the exponents on the inside. Okay, so that means we're starting off with 8 to the 6th times 6 power. Okay, 6 times 6 is going to come out to 36, so we get 8 to the 36th power here. Then we've got that 3 to the 7th. I'm going to take the 3 to the 7th, and I'm also going to multiply the exponent by 6. And that will give me 3 to the 42nd power. And there's my final answer. I don't multiply these powers together because they are not of the same base. Remember, it has to be a single base. Okay, let's try problem number 5. Again, we have more than one base. We have a 5 raised to the 4th power. We also have a 2 that's raised to the 10th power. So I'm going to separate those out. I'm going to focus on 5 to the 4th. I'm going to highlight that in my orange. And then my 2 to the 10th. I'm going to highlight that one in my green. And then the exponent that's going to get multiplied out is the 4. We're going to distribute it to the 4th power, and we're going to distribute it to that 10th power. Right, so let's start off 5 to the 4th. That gets multiplied by the 4. And then we've got 2 to the 10th. That also gets multiplied by the 4. And our new exponents become 5 to the 16th power and 2 to the 40th power. And there's our final answer. Okay, let's take a look at problem number 6. Problem number 6, we've got 3 bases here. We have 3 separate bases. We have 4 to the 2nd. We've got 3 to the 5th. And then we also have 6. Now 6 doesn't have an exponent written, but we automatically know if it doesn't have an exponent written, there is an invisible 1 there. Remember, when an exponent is not written, there's always an invisible 1. Okay, so I'm going to rewrite these. I have 7 to the second, I have 3 to the fifth, and I have 6 to the first power. And each of these exponents is going to get the 4 on the outside distributed to it. So we're going to do 4 times the 2. We're going to do the 4 and get distributed to that 5. And then we're going to take the 4 and distribute it to that 1. And our finalized answer is 7 to the 8th power, 3 to the 20th power, and then 6 to the 4th power. Final answer. It's really very easy. You're just distributing by multiplying. Okay, let's take a look at the last one. Again, we have several different, or not the last one, the second to last one. We have several different powers here. We have 4 to the third. We have negative 5 to the fifth. Don't forget those negatives need to stay inside what? They need to stay inside parentheses. And then we have a 9. And the 9 does not have a power written. If it doesn't have a power written, we know there's an invisible 1. Okay? So we have 4 to the third, negative 5 in parentheses to the fifth, and then 9 to the first, and each one of these is going to get multiplied by that 3 that's on the outside. 3 times 3, 3 times 5, and 3 times the 1. Okay, so this now becomes 4 to the 9th power, negative 5 in parentheses to the 15th power, and 9 to the 3rd power. There's our final answer. All right, last problem. We have 8. Problem 8 has got negative 4 inside parentheses raised to the 2nd power. We've got 6 to the 5th power. And then we've got a negative 2. It doesn't have a power written, but remember, there's always that invisible 1. And then, of course, we've got the 8 that's on the outside. That's going to get distributed to each of these components on the inside. So we have negative 4 to the 2nd power. It's going to get multiplied by the 8 and become negative 4 in parentheses to the 16th power. Then we've got 6 to the 5th power. That's going to get multiplied by that 8, and it becomes 6 to the 40th power. And then lastly, we've got that negative 2 to the 1st power. That's going to get multiplied by the 8, and that becomes negative 2 to the 8th power. And that's our final answer. Okay, you have an assignment that is on Google Classroom. It is a quizzes. You get one chance and one chance only to be able to do that assignment. So take your time, do the best you can. It does need to be finished before class is over.